Alright, so what we're going to start tonight with is an introduction to ellipses, which are the oval-shaped graphs. And we're going to do this for a couple of days. So today we're just going to practice the graphing and finding the different parts, like the vertices, the center, the foci, and the eccentricity, which I'll talk about what all that is here in a minute. And then the next day we'll work on how to go backwards, writing the equation given parts of the graph. So just like with any of our conic sections, we have to know what the equation looks like so we know how to read it. So standard form of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So some things that you want to note about the standard form: hk, that's our center. So the center is hk, just like it has been in the circle and in the parabola. The equation has to also always equal 1. And so that's going to come into play a little bit more when we start having to convert or make sure we have an equation in standard form. We need to make sure it equals 1. And then we also have what are called vertices. A and B help tell us what the vertices are. So these together will tell us the vertices, and I'll go through how they tell us. So our ellipse can go in two directions. We can have a vertical or a horizontal. So if we had a horizontal ellipse, it's going to look something like this, with your center at HK, and then you have these 2 points here, which are called vertices. And vertices are always on the major axis. Oops, M-A-J-O-R, axis. And what the major axis means is if you were to draw the line connecting all three of these, it's going to be longer than what's called the minor axis. The minor axis connects the covertices. Which are always on the minor axis. And so if we look at our vertices, so in this case, this is A and negative A. This is B and negative B. So A and B, A here, we would take the square root of our denominator, so the square root of A squared. That will give us the distance between our HK and our vertice, and then go the opposite direction to get the other one. B, the minor axis, will be a smaller number. So in this case, A is larger than B. That's how we know it's going to be a horizontal, because A is greater than B. Square root the other one, you get your other two vertices, your covertices. Now if this was, excuse me, if this was vertical, so again, I don't have these on any axes, we would have our HK still in the middle, but now we'd have B and negative B are the major axis, and we would have A and negative A be the minor. So in this case, A is less than B. So the trick to know what direction your ellipse is going to go, whichever denominator is bigger, that's the direction that your ellipse will go. So if a squared is bigger than b squared, then it's going to be a horizontal because it's under x. If b squared is bigger, it's going to be vertical because it's under y. So that's kind of the quick trick that we use to help us determine direction of our ellipse, is which denominator is bigger, the one under x or the one under y. Okay, the last piece that we have for our graph is called the foci or foci. I've heard it said both ways. I personally don't really care. I use them both interchangeably. So the foci are always on the major axis. So if we were to go back up to our horizontal, our foci are going to be points in between the center and your vertices. Now, by definition of an ellipse is created by having what's called a constant sum of all these focal radii. So if you were to pick a point and add the two radii that go from that point to your focus, as you move around your ellipse, that sum will never change, even though the radii length will. So that's why the foci are important, are just because they help us with that definition of a constant sum. And that constant sum, we don't really use it a whole lot here. But if it's necessary to know, I'll let you know. I want to say it's 4a, but I'll have to double check that. It's either 2a or 4a. I think it's 4a. But no, it's 2a. No, it's 4. I'll think about it and see if I can remember what it is. Okay, but the key thing is that you have to know that they're always on the major axis. So if this is your major axis, then your foci are going to be plotted on that axis. If your vertical is your major, then your foci will be plotted on the major axis that's vertical. Okay, the last little thing, and this doesn't necessarily go on the graph, but it's something that we use every now and then, and it's called eccentricity. What this tells us is how much of an oval or how much of a circle this is going to look like. So sometimes an ellipse can be really circular looking because A and B are really close to each other. They're numbers like 2 and 3. So your major and minor axes are going to be really close to the same length. But sometimes they're really far apart, so it looks more oval. And so we have a way, eccentricity, to tell. And how you do it is it's F over A or F over B. You use whichever one's larger. So let's say you had a vertical ellipse. I'd use B because B is going to be bigger than A. If I had a horizontal, I would use the F over A because A is going to be bigger. So whichever one is bigger is the one that we're going to use in our formula. Now, for eccentricity, how do you find F? F is the focal length. There's a formula, F squared is equal to the absolute value of A squared minus B squared, and that's what we're going to use to find F in for our eccentricity formula. So if you want, you can say this is focal length. Now, how to tell once you actually have this eccentricity value? If your eccentricity, it's always going to be between 0 and 1. The smaller it is, the more circular your ellipse will be. So the closer to 0, the more circular. The larger, or in other words, the closer to 1, is more ellipse or elliptical. And so that's just how we use it, is to help us determine how circular or how elliptical our shape actually is. So we've gone over just all these basics about the different parts of an ellipse, but now we're going to actually practice sketching and finding these different pieces. So I want to go through at least one here and then two in class, so that way we can make sure we're good on how we graph an ellipse. So the one that we're going to graph here, we're going to find the center, the vertices, the foci or foci, and the eccentricity, and sketch. Now I know it sounds like a lot, but when you put this into action, it's one of the ones that can go pretty quickly. So our equation, x minus 2 squared over 9 plus y minus 1 squared over 4 equals 1. I'm just going to draw my axes over here. Alright, so first off, our center. That's HK. So looking at it, we find it the same way we've done the other ones. So H would be 2, K would be 1. So 2, 1 is our center. So we can come over to our graph, 2, 1. There's our center. Now the vertices. So these are the bigger numbers. So which one's bigger, 9 or 4? 9. So that means for my vertices, I'm going to take the square root of 9. So the square root of 9 is 3. So that means my vertices are going to go from my center 1, 2, 3 to the right, and 1, 2, 3 to the left. So the ordered pairs I get there are 5, 1, and negative 1, 1. Like the formulaic way to say this is because it goes horizontally, it's going to be x plus a, y, and x minus a, y. So it's going to be that same value that you had for your center. So I guess I should use h and k so it's consistent with the hk's in the vertex. So h plus a, k, and h minus a, k. If it goes vertically, then we would have had h, and then we're adding b to the k value and subtracting b from the k value. Or you can just plot them knowing that it's this distance of 3, and then read the ordered pairs from there. Okay, so now we also want to plot the co-vertices, even though it didn't ask us to label them or find them in our list of things. We do need to find those co-vertices just so that we can sketch the ellipse. So our co-vertices are going to be the square root of 4, so that's 2 from the center. So 1, 2, 1, 2. So right there, I have enough points, because it's very similar to a circle, to connect the dots and sketch the ellipse. Now these ones should look more ovalish than our circles did the other day. They still should not look like diamonds though, so you need to really try to curve out your ellipse. Okay, the last thing we need to find are the foci. So let's see, our foci, or foci, I didn't give you guys the formula for that, did I? Well, actually I did. It's right here, this focal length. So if we come over here to the side, we have f squared equals the absolute value of a squared, so a squared is 9, minus b squared, which is 4. So we have equals 5. And then so that means f, or the length of our focus, is root 5. So what that means is if I were to start at my center and go square root of 5 this way and a square root of 5 this way, I would get my foci. So square root of 5, this is where we would need the decimal approximation. So it's a little over 2. So 1, 2, and a little bit. 1, 2, and a little bit. There are your two foci, or foci. So when it comes to the writing of the ordered pairs, again, we started at 2, and we added root 5, 1, and we started at 2 and subtracted root 5, comma 1. So for the foci, it's very similar how we write it with the vertices, where we are adding and subtracting to our h instead of our k. Now if this was vertical, we would just be adding and subtracting from k as opposed to h. And then the last thing it asked for was the eccentricity, which is f. So here f we'll say is root 5, over, now which one was larger, 3 or 2? 3, which is about 0.75 when you actually do the division. So this is closer to 1. So because it's a little bit closer to 1, yeah, it's a little bit closer to 1 than it is to 0. So it's going to look a little more oval than circle. So like I said, we're going to go through 2 more like this. One where we also have to change it to standard form. But we'll do a vertical one, and we'll do one that we change into standard form as well, and find all these pieces. So again, come with questions. It's a lot of information. It's a lot of new information. So come with questions so that way we can get those clarified and then go through our 2 other graphs that I want to go through with you before we get into the work for the day.